pasamos quizás al siguiente.
Okay, so we'll move on to the next speaker.
Nos vamos a Chile.
So we're going to Chile,
Que creo que es bastante.
and I think it's pretty early. I think it's something like, what, 4 o'clock in the morning?
Debe ser tempranito por allí.
Or 5 o'clock in the
Pues
morning?
nada, adelante.
Well, off you go then, Mariano.
Y a ver la obra. Buenos días.
Morning.
La obra de Mario Carreño.
It's the work by Mario Carreño, who's an architect at Carreño Sartori in Chile, and he's going to present the title of his presentation. He's going to be talking about assembling and using wood in different projects, and not only in family dwellings, but also other kinds of buildings in Chile. So go ahead, you have the floor. Good morning, everybody. Well, this made us think very carefully about what's going on in the world of architecture, but the truth is that we've been pretty busy lately. And firstly, we have the issue of timber, which we think that, well, the education that we received at least through catalogues and manuals and through a number of recommendations is something that can't be forgotten. And these recommendations are only focused on the economic aspects. And then the closures or the claddings that are either continuous or discontinuous, so they are ventilated or wind-tied. But these are recurrent issues. And these are solutions that have been consolidated over the years. So architecture is, well, does not only have to be based on what is said in the technical manual. So this is why, well, this is why I'm going to be talking about frames and singularities, because I think that's the same kind of frames. And here we have, for instance, this work by Gordon Mataclan. Where he cut a traditional dwelling and made it something unique in a creative operation, and which also has spatial effects by opening up or by providing a connection with the external part. So, as I mentioned before, we are working quite a lot with lots of construction principles, different construction principles based on different ideas and techniques that are accessible according to the regions of Chile that are so diverse. There's a lot of very diverse technical capacity, but this variety has to be simplified whenever you do architecture. So this is why in our world and in the academic world, where my partners and I working at the Catholic University of Santiago as guest speakers, our activities are focused on the work site itself. So what we've done is develop construction techniques. Well, this is what Godofredo Uni said. It's always the same thing, but it's never the same thing or never identical. So this is some of the things that we've learned as if we were carpenters over the years. And each project, each brief, and even though it has to do with the systematic approach of what the manual says, in the case of timber, it's all based on observation, on observing what life is all about and on what shapes are all about. In other words, observation based on the technical and scientific criterion and from a poetic and landscaping perspective too. And this is conducive to a proposal, which is a minimum common denominator. For instance, in the case of a building under a tree, and then we move into specific landscaping elements. And finally, the architectural shape is a creative proposal in this respect. And it was Godofredo Yomi himself who said that man was permanently engaged in building the world. And this is what we are doing too, up to a certain extent. And here we can see how different projects have a technical approach from the constructive perspective. So the first project dates back to 2001, and it's dwelling in Palmas de Ocoa. And it's located on this edge of the La Campana National Park. It's a mountain range there that has been declared as the World Heritage Site. It has lots of vegetable species and lots of animal species, and the geographical aspects are very interesting. The Concagua River flows this way through the mountain range, and this valley of Ocoa, it rises very slightly here along this ridge, and this is when you reach the site. They are like, I don't know what to call them, terraces. And there's, well, vegetation that grows in the central Chilean valley, which is a semi-arid climate, where we have these trees, and the Chilean palm tree, which is a national monument for Chile, and these, well, paths that are used by animals and people, but this is a living reserve. So there's here something that we had to learn about first, something that has to do with our geography, and that is the constant presence of these ridges. And this is the area that is next to Argentina, where drafts are formed when the air is warmed up. It goes up and then goes back down again when it cools down. And then there's a recurrence too in the case of the slopes of the ridges. And the valleys, it's 2%, then this goes up to 10%, and you can end up at 30%. And which would be this profile. This is the classical profile of the Naipo River, which is the main river in the valley of Santiago. Well, it's a river, but there are also many streams too in Chile. Well, they're not seaworthy, of course, and there's no water in the summer months. But this is what I want to mention too. In Chile, there are many types of wood, although, well, there's a strong timber business that is based on Pinus radiata, and after many studies on the growth of speed, this is a tree that was brought from outside Chile, but it grows very quickly, and it's also very resistant, meaning that it's very attractive from the economic perspective. So this is why I wanted to show you this chart that already included the pine trees in 1956. These are the first studies that date back in Chile to 1930, approximately. But there are other native trees that still exist and with which you can also work. Well, they are 5 times more expensive, but they have other values. Oak and the Rauli, which is a very stable kind of wood, and Coibe, which is resistant too, but bends a little bit. And the larch and alenga, well, there are many kinds of wood, and there's a tradition, especially in the south of Chile, where all of these this wood comes from, where there's rains a lot. They use this for architecture and to build ships or boats. And this is something that we've also tried to include in our catalogue, although up to a certain extent, because we are in an industrial system. So in this first project, and what it did, at this very warm place, but with these drafts in the afternoon, we suggested that we elevate volume to have the view over the ridges of the Cerro La Campana y Cerro Los Robles and the Chilean palm trees that can be seen in the forest. And well, quite simply, and here, well, we go back to this idea of the frames. Well, we suggested 6 frames located every 3 meters based on 3x20s to achieve maximum efficiency. And in this innovation, we also, well, considered the use of either wood or steel. And for the first time, let's say that we established a connection with steel because it offered lots of resilience and lots of flexibility. And well, we developed this shade in a warm place, and that's something that you have to feel happy about, but also allowing that there be air circulation below the building and also above the building with the ventilation provided by the eaves. And here, well, this is another picture where you can see the shade that is produced, and then the soil has lots of thorny vegetation and lots of rocks. And instead of using these supports where the wood is overlapping the foundations, what we used was layer of reinforced concrete that also provides rigidity for the structure.
I was just saying, or talking about this simple calculation. It's 4.5 meters wide, and this is 152 in size, not the traditional size, 122, and 3.10 is the total length. And the engineer asked us to make a 150 centimeter column, and the traditional walk, which is 2 by 4 inches. In this case, we made it 6 times 1.5 inches, which is a volume of wool that's almost equal, but provides an 8-inch wall, which provides a different thickness to the timber construction, which we also thought was interesting. Well, from these basic maths, we obtained some drawings with the minimum elements. This house was competing with low-cost prefabricated buildings. And the final result was able to compete with that. And we can see how it integrates with the forest. And instead of being an airtight box, it's connected to the land and the park and this private reservations. It allows the passage of people, wind. The second project was the National Zoo in 2006. In this project, there's an academic exercise. Our second timber project, in the first one, we had to think about material efficiency. And in this second case, we took the work done by Jorge Oteiza, a Basque sculpture, to unfold volume based on an academic exercise. This cube, which has a spatial structure, if you unfold the sides, it offers a spatial complexity that is related to the outside. This is a metropolitan Santiago. We have a hill, as in the previous case, and this zoo is inside this park. It's a zoo opened in 1825, and it's difficult to walk around this area. It's quite hilly. the Ministry of Housing, more than moving it, because there have been projects to move it away to flatter areas, but it's so close to schools, to children, that it was decided at this point to start to improve it through several public works contests. Here we have the veterinary clinic, the dining area for the staff, and this is the elephant area and the main entrance. And you can look at the elevation, and these are platforms and terraces on different levels. The vets had to carry a tiger on a stretcher up some steps to get it to the clinic. So we consider this a prosthesis to try to facilitate the routes and make the most of this central view on the city, which is beautiful from a balcony. And different levels were established with a ramp. And the work groups are separated on this terrace. There's a work group for vets. There's an area for the maintenance staff, and this is for management. And this is where the feed is prepared for the elephants, for the camels, for the different animals. They mix and prepare the nutrients here. And here we can see the slope of the hill and how the building is inserted like a prosthesis. This is a ramp that now makes it possible to carry the animals on a stretcher up a ramp. This is the office area and the food preparation area. And here underground is where they breed rodents, which are also food. And here, these axes that are quite simple in the plan view serve to unfold Ortega's box or cube, as we saw at the beginning, and makes a more complex relationship between the regular frame and this access area for vehicles that can also carry animals. And the area is very narrow in this central area. And it'll also allows air currents to come in and generate some shade. The roofing covers half of the area because vets work in the open, and they've set up their desk in this area, which has a roofing, but it's open, and they work here in summer, and they meet in these outside areas. And there are different sections showing the complexity of the project, inserted in these various levels and terraces, etc., which are finally enveloped. This is the area where I said that the work teams work together, and they sit in this area. And there are these cutouts that provide a view. And this is the center of Santiago and the business center. And these are the trails and the hillside overlooking the city. And it's very restful. It also provides a framework for previous constructions. In this case, the metal structure is inside and is not exposed, as in the previous case. And these are unfolded or deployed planes following this idea of Lattices sculpture. We also made wood out of plywood. And this is koiwe, another timber with a different color. It's a native wood. And the cladding is radiata pine. And outside, we painted the project with a byproduct of copper. Chile produces copper, and that copper-based paint is a bactericide and a fungicide. And here we can see the volume and the empty area inside with the ramp and so on. In 2007, I was commissioned to work on a house from '86, this house in the back, which is also on a slope. And it's located, well, this is the Mabocho River, the central river in Santiago. At this crossing, there's a very old sector that is now near the center, but it used to be a sort of weekend location. Nowadays, people come here. This is the original house from 1976, which had a radiata pine structure, but a Rauli lining, a fantastic species in Chile, with very stable grain used for windows, for furniture, and is excellent for linings because it practically doesn't change shape and resists humidity very well too. And this faces south and is exposed. And in this highly consolidated area, we considered a minimal intervention, which was to be a tower. This tower is no more than 6 by 6 meters with 3 levels. And with this vertical construction, the house is separated into two horizontal areas. The previous house had 2 levels. These 2 departments or apartments offer horizontal living and turn a single family home into 2 single family dwellings for the children. Another point that we thought was important with regard to the geography, this valley looks onto a fairly dry hillside, and the view in the distance is much more interesting and actually goes as far as the center of Santiago, 15 kilometers away, and towards the Dapocho Hills. And this tower opens up the view along the box, although we have a perpendicular route. In the living room, this view opens up, and on a clear day, you have a 40-kilometer view. You can see the summit along the coast. And these balconies have an open 360-degree view. And here again, we work with steel structures, these 3 legs that form the tower, and also steel structures to support this ventilated and open louvers. And this has a relationship with the leaves, with the vegetation. This is the lower level. These are the 3 legs I mentioned, and each one of these legs has a pillar system, and these diagonal struts timber was used for bracing previously, but since the old house was completely timber, and a metal structure was much better for the tower. This is 100 by 100 millimeters, and there's a double casing. In this case, it's separated into two casings of 2 by 2 that go outside the metal structure and outside the diagonals and offer a continuity of timber. You can't see any metal except for the veranda, but that continuity is preserved in the original house, and Rowley timber is also used as a lining. And the Rowley trees have changed. The old forest died out, and now they've been replanted to be used as construction timber, but they're not as high quality as before. But here, in any case, the metal structure is integrated into the timber structure. Another interesting thing about this terrace is that the house was sort of sunk in the southern hill, where there's no sunlight in Chile. It's different to the northern hemisphere. And in Chile, this is good for wood because it doesn't dry it in this area. But this elevation looks out onto the street. It's a street with very little traffic. So this inflection looking out from inside the building to the river and the box connect the distant views with these interiors, let's say. And we can see that these legs stick out. They're like benches, and this transparent veranda gives us this feeling of sort of floating on top of the box. And this is a picture of the interior looking out on the box. We can also see the furniture. This is by Cristian Valdez, National Award in Chile, one of our maestros in the use of wood and timber. And again, we can see how the view opens out into the distance. The construction of this tower, there was another contest the following year at the zoo. Well, there were several contests. And this is located in the same area of the Metropolitan Park. And this is animals are taken that are abandoned by their mother, or from other areas. Some frogs have just been brought in from the north where the streams are drying up, and they brought in these frogs from this unique species, and here they kept them alive. So the contest proposed the volume for the intervention, and this volume was separated into two parts, and nothing could be touched in these 1920 walls, so it's a self-bearing structure. And this separation was meant to preserve the view of the hill instead of covering it up. And once again, this was designed as a sort of prosthesis. Since there are frogs here from cold areas, or llamas from hot areas, there are different areas that are very well insulated, and there was the requirement to meet with this complexity of metal structure, polyurethane, insulation, etc. And some ventilated timber was used to create a shade and ventilation, and it's more difficult to preserve cold than heat here. And we see here how the original walls haven't been touched by the structure. And there's this basement where the labs are, holding up the rest of the building without affecting the walls. And here we can see the lower and upper areas, and this is where the frogs currently are. And this will end up being covered by vegetation and plants. And this is how we combine the interior and the exterior and the route for the vets from the various levels. And on the outside, we have a visit from these students that come to see the animals. And the zoo covers the whole country in caring for national species. They don't just display the animals, but they have a preservation role. Another project is the Salamanca Gymnasium. This is the Tambo Valley, the Rio Chuapa Valley, and the River Chalinga Valley. And there's a slope here of 7%. This is the central village square that goes to the cemetery with the regional government, the stadium, and the cemetery, and the various institutions. And it's a very pretty geographic situation, because there are different cultures at the various rivers, and from here we can see the geographic meeting point for these valleys. This was also a public contest, a public tender, and we were very pleased to be able to work on a public tender. There was an old swimming pool from 1950 with lots of cracks, but it was embedded in people's memory. And then there's a football pitch where a third division team plays. And there was an old gym in very poor condition. And these facilities were separated by walls. So the gymnasium was proposed for the contest. And it was proposed that a sports area be created and the walls done away with it. In the end, the swimming pool couldn't be saved, and we proposed that this area be recovered as a public space, while remembering the old swimming pool, but turning into an encounter space. This then was dedicated to a public space, and this slope was leveled, and this is the horizontal plane. The street still has a 5% slope, but this is turned into a horizontal plane. And here in the back, dressing rooms were installed for both the gymnasium and the football pitch, and this is an ambulance entrance that didn't exist before. So all this formed part of the same facilities. This is the street, and there's a subtle difference in slope. And this provides a large shadow that was initially proposed. Under the stands, and they weren't very good stands, but by adding this public area, the whole space improved. This lasted, I can't remember, 6-9 years because the construction company went broke. The project stopped. It took quite some time. But the mayor was determined to dedicate this area as a public space. And this reminds us of the zoo project, this like a paper aeroplane or an open cube. And here we proposed a method to reflect the light. The light here reflects on the ground, on the wall, on this skirting. And here they practice sport with natural daylight. And the lining is separate, and air comes in through the top. It comes in through here and comes out through here. According to the ascending current or breeze. And this was the design. It was implemented in the project, and down below we have the dressing rooms and the amenities, and here we have the public entrance to the stands. It's always important to manage crowds in sports facilities because large crowds can be involved. We work with an architect, Sarracin, who was a partner in several projects and who has taught us quite a lot. And this breaks with the roofing tradition. We have a length of 61 meters that we wanted to cover with timber because of the acoustics. This wasn't just a gymnasium. It's very big. It's also a place where concerts take place. It's like a city hall. And Mauricio worked on oil platforms in Petroliera in the Magellan Straits. And we decided to include a steel beam or girder over this prosthesis, which was made of reinforced concrete, and it's 35 meters wide to hold up the 61 meters of the wooden beams. These are two 28-meter beams, which join at the center. Here it's supported on the steel structure. There's more than 40-meter span. And the greatest difficulty in these elements was prefabricating them. They had to make them outdoors with the risk of running problems with the sunlight. And also, this town is out of the way. And the road is a windy, slopey road, and they wanted to divide them into 3 sections, which was a nightmare for us. We even considered deliver them by helicopter. They use helicopters to remove large trees from the forest. But they found trucks that have a dual control at both ends. And with that, they were able to navigate the windy roads and arrive on site. This is a mixed construction project. And here we can see the wooden plane, the inflection. There's an aluminium lining that we also commissioned. We ordered the aluminium plates with no finish, with the idea that they would turn matte in time, and they were cut to size, and an aluminium structure was designed to support them. And here, once again, a recurrent issue. The planes are unique. This is the plane of the skirting that reflects the light. This is the concrete ramp that takes us to the protected shadow area. But in this case, the timber wasn't sawed timber that provided the 3.1 or 3.2 meters. In this case, the pieces were made to order, and the size is 6.47 or 6.5 meters to cover the 61-meter span in the gymnasium, and the beams are 60 millimeters high. And finally, beams 2 by 6 to receive the bracing for the exterior contralaminated wood. And this steel plate for the roofing is industrial roofing and includes the insulation.
The wind enters in this point and leaves around the back, and there's an element that provides rigidity for the edge. And these are the floor plans from the engineering firm, and where we have all the dimensions. And the factory also adjusts to the laminate elements, and I can't remember the thicknesses now. I think it's 16 to 18 centimeters. And well, we found that engineering was very interesting too, because this is made of reinforced concrete and steel and wood. There were many joining parts. And this is a second project where you can see these elements, and once they've been assembled on different kinds of material, steel, wood, concrete. We have lots of earthquakes in Chile, so this is why these fixations can slide. They can slide up to 10 centimeters, so everything has been made mobile. And you can see these prefabricated components that reach this very distant location, and how they assemble them with a very basic technology, with well, using scaffolding. There's a crane too, of course, but in any case, this is the finished product, the end product. This is all done on site. It's very light. There's also a gym, and there's a basketball court for youngsters, and it's worked very well in the community, so we're very happy. And it provides shade too, which in this central and northern area is something that is very valuable. Here you can see the technical circulation in the upper ring. And here there's a booth that is used by the news commentators to deliver their comments on football matches. And here we have some metal tension bars, but you can see the angle fixation elements and how the seating is joined to the vertical plane. And once again, these eaves, it's skirting boards. Over here is the cafeteria and the gym. And where light gets in via the rear part of the building. And to conclude, then, this is another house in this place that I showed you at the beginning. This is the Cerro Bochoco. The other one's on the southern slope, and this is here on the northern slope. It's a wild location. These are beautiful locations. It's all native vegetation that is preserved by the rainfalls. And in this case, the slope, the house was situated here, as you can see, and we proposed several terraces. A terrace for the living room and another terrace for the children. Now we have this external flooring, and we suggested this external flooring system to gain a little bit more space because the rest of the plot is infinite, and we built this terrace with these external walls. And there's a bridge that leads to this last terrace. So what it is basically is a spiral kind of structure. You drive up with a car, you park here, and the kitchen is over here, the swimming pool over here, and the living room that has a view. So does the kitchen through this window, which is a large window. And there's also an external corridor that follows the Mediterranean architectural tradition, which we've applied in Chile too. And this also overlooks the ascending drafts. So there's an increase in the wind speed and there's lateral ventilation. And well, this line goes this way and then goes up. And in the upper section, there's an outlet. So air can enter through the eaves to remove the air that's inside, so the house works perfectly well, thermally speaking, thanks to this constant ventilation. And here's the second story, and this is the terrace for the children. And this is something that surrounds the entire house. And for him, I can reach the ridge once again. And here we have the 3 metallic H's every 3 meters. But now we have these much better developed climatic floor plans, but you can also see how there's a view over the ridge. Well, there are multiple views. In the Cerro Choco, there was an alignment with the enclosure itself, and well, this has to do with the gym, and it has to do with the wind and with the shade and with the orientation itself of the building. So there are many kinds of frames. There are double frames, and at Bochoco, where we have the bathrooms here, and solar panels have been installed on the roof. There's a beam, and there are 2x3 and 2x2 and 2x4 frames. So there's a greater subtlety in the development of the frames. But as I said at the beginning, there's lots of simplicity because we work with black rolling that's installed on the outside. You can see the forest from this window. We had an excellent professor with us called Fabio Cruz, who taught us many things, and well, he was the initiator of this particular school. And he told us that I had to resist applying varnish on the outside of the house. We think that that's an interesting concept, so what we used in this particular case is an external paint for the wood. And you can see the skirting board in reinforced concrete, which is something that we have installed in a recurrent manner. And then the flooring is another of the components. So this is what I would call disperse control, environmental climate control element. And I believe that this architectural layout is, well, it's a very important thing for one's life. Well, this is the floor plan on the one hand, and over here we have the furniture plan, and in this case we're talking about an Amazonic cedar table. That is a very important element. Here you can see the pool, the garden and the lounge, and how the shade can be generated. Well, depending on the season of the year, the sun changes a lot, and lots of trees were planted too to protect the house. We do architecture and landscaping too at the studio. So these are landscaping operations that are totally in favor of the architecture that is developed. And you can see how the diagonals provide protection. You can see the shade. You can't see the wind, but it's circulating in this area. It comes from this valley and reaches the center of Santiago. And these diagonal elements open up different tracks in that perimetral trajectory that is inspired by what we would call traditional corridors. And well, here you can see what I said before, and this is the work in wood that has another very interesting thing, and it's well, it's a different temperature you get thanks to the wood. We have the different floor plans and the continuous terraces and the staircase, the view over the ridge, and well, and you can see the terrace over here as a final element. And that's my presentation. And here you have the credits of this work with the people that have worked with me at the office.
Muy bien. Mario,
Thank you very much. Thank you very much indeed for your presentation. We've seen a very interesting number of works that are not identical, but by paraphrasing Godofredo Pauli, we can say that it's always the same quality, although perhaps you're improving all the time. But I just wanted to ask you about timber construction. Well, it's obviously when you participate in the tendering process, you decide that you're going to be using wood for these frames. But when it's a private customer, how can you convince people to go for wood? Is it because of the construction tradition, because it's light material, because it's very resilient in the case of earthquakes, or because it's because of sustainability or tradition or color, or something that has to do with texture, something tactile? Could you please elaborate on that, please? In Chile, timber architecture was something that was criticized a lot because it's associated with a certain degree of poverty. Because it's considered to be an old-fashioned material. I've been in close contact with wood for a long time. But you have to use the right kind of wood according to the level of humidity. And well, this is something that has grown in Chile because, as I said, there's a very strong presence of the forestry industry. There are lots of pine wood producers in Chile now, but we need much more industrialization from the point of view of certification, resistance, etc., and stability. And lots of progress has been made, but we have to have fully certified timber. But I think that in the last 30 years, and a short time ago, there was project in wood that's 20 years old, and we spoke to customers and they were selling it and they were impressed because, well, the house was very expensive, extremely expensive, and it was sold immediately, although nobody believed that that was going to happen. So we in touch with private customers, and let's say that they opt for wood. But nowadays, people want certain elements of quality, sustainability, temperature conditions, and I think that this is becoming more and more of a cultural issue, and lots of progress has been made. And there are many opportunities too for timber projects. But Chile is, geographically speaking, a very wild country, but it has lots of very high quality timber architecture. So this has reached the domestic sector. Wood is something that is completely feasible. For instance, in Valdivia, there are wooden houses that are 100 or 200 years old. So this proves that they are very resistant and they survive for many years too. Well, we'd spend another half an hour with you, but I suppose that you are tired and you deserve to take a rest now. So I hope to see you again soon. Goodbye. Well, thank you all for your attention.
Laile, en Urnieta, a 500 metros de la ITV y a tan solo 10 minutos de Donostia, la mayor exposición de suelos de madera para tu casa y también para tu terraza. 1.600 metros cuadrados de suelo a tus pies. También tenemos puertas y los nuevos revestimientos pensados para tu cocina y baño. De lunes a sábado te ofrecemos un equipo profesional para asesorarte. Maderas Laile, 2 generaciones a tu servicio.